Good morning, ladies and gentlemen. All right, today we're going to take a look at section 3-4, which is solving exponential equations. And we're going to do this specifically without calculators. And the way we're going to do that is we're going to look at the base value on each side of the equation, and we're going to change the base value so that they're the same. And by doing so, it's going to allow us to set the exponents equal to each other and use the exponents to solve the equation. For instance, on question number 1, you will notice that we have a base of 64 on the left side and a base of 4 on the right side. And the first thing I want to do here is I want to change the base on the left so it matches the base on the right. In other words, when I say that, I want to take the 64 on the left side and I want to write it as 4 to some power. Now, if you think about it in your head, you can probably come up with it pretty quickly. We know that 4 to the third power is 64. So I can rewrite the left side as 4 to the third power, and then the right side I can leave as 4 to the power of x minus 10. So in changing the base to match the right side, if the base 4 on the left is equal to the base 4 on the right, then the exponent on the left must be equal to the exponent on the right. So now all you have to do is take your exponents, which is 3 and x minus 10, and set those equal to each other, which is what we're going to do right now. We're going to take 3 and set it equal to x minus 10, and we'll add 10 to both sides. So we'll add 10 to the right and the left, and it turns out that x is equal to 13. And you can check that very quickly. If we plug 13 back into the equation, we would have 64 equals 4 to the 13 minus 10. And so the left side would stay 64, the right side would become 4 to the third power, and we all know that 4 to the third power is 64. So we're able to solve this equation without even pulling out a calculator, and all we have to do is make the bases match on each side. All right, let's try it again with problem number 2 here. Okay, I have a base of 3 on the left and a base of 9 on the right. The smaller base I'm going to leave alone. The larger base I'm going to change. Now this one's a little bit different because what I want you to do this time is I just want you to ignore the exponent that's attached to the 9. And all I want you to do is I want you to rewrite 9 as a base 3 problem. So we would say that 9 is equivalent to 3 to the second power. Alright? So that's equal to 3 to the second power. But that exponent of x that was there needs to stay attached to my problem. So right now I would have 3 to the second to the power of x. And then I'm going to use my exponent rules and I'm going to put these two exponents together. The rule here is multiplication. So I would multiply 2 times x and I'm going to get 3 to the power of 2x. On the right side now. The left side is still 3 to the power of x plus 3. So by changing the base 9 into a base 3 problem, I'm then able to use my exponent rules, multiply the 2 and the x, to create a base that's equivalent on the right and the left. And now I can do the same thing that we did before. If the bases are equivalent, then the exponents must be equivalent too. And I can take x plus 3 and set it equal to 2x. And then from there I can solve. So I'm going to subtract x on both sides here. And I'm going to get 3 equals x. So in this case, x is equal to 3. And again, you can check that out pretty quickly and easily. Some of these are easy to check, others aren't going to be so easy to check. But if I plug in 3, I get 3 to the power of 3 plus 3. Equals 9 to the power of 3. Looks like we have a screen issue here. Give me just a second. All right, let's keep going here then. Hopefully that doesn't happen again. All right, so if I plug in 3, I get 9 to the 3rd on the right. I get 3 to the 6th on the left. And if you take out a calculator, you'll find out that 9 to the power of 3 is 729. And if you punch in 3 to the power of 6, you will also get 729. So my answer of x equals 3 checks out, and it's good. All right? So what I want you to do now for number 3, I want you to attempt number 3. You can either ask the sub to turn off the video for just a second, and I want you to change the base on the right side to match the base on the left and see if you can solve number 3. Okay? So just have the sub click the pause button and then take a couple of minutes and try that one. Okay, so we're back, and the right side we're going to change from a base 4 to a base 2 problem. So again, if you ignore the exponent here, you would write 4 as 2 squared, but we still have that exponent of x minus 1 that's attached to that, and that's going to be equal to base 2 to the power of 3x plus 1. On the right side, I need to combine my exponents, so I'm going to again multiply 2 times x minus 1, so I'll leave the base of 2, but now it has a different looking exponent. It's 2x minus 2. The left side stays as 2 to the power of 3x plus 1. And now that the bases are equal, we can set the exponents equal. 3x plus 1 equals 2x minus 2. And we can go ahead and solve this. I'm going to subtract 2x on both sides. And I'll go ahead and subtract 1 at the same time, bringing that over to the right side. So on the left we end up with x, on the right we end up with negative 3. Okay? Number 4 gets a little bit trickier because now we're dealing with fractions and or fractional exponents. But we still look at the bases, and you can see that the base of 5 on the left, you cannot break that down anymore. So the left side we're going to leave alone, and the right side we're going to give an equivalent base. In other words, we're going to break 125 down into 5 to what power? To the 3rd power. So I would write 5 to the 3rd power. I would raise that whole thing to the power of x minus 3. And then the left side, so now that we've got our bases the same, we're going to leave the exponent on the left side as 1/2 x plus 6. On the right side, we still need to combine the exponents just like we've been doing, so we would multiply. So we're going to have 5 to the power of 3x minus 9. And on the left side, we have 5 to the power of 1/2 x plus 6. And just like before, once the bases are the same, we're going to go ahead and set the exponents the same. So I would set 1/2 x plus 6 equal to 3x minus 9. I need to subtract 1/2 x on both sides. Subtract 1/2 x. Subtract 1/2 x. I'm going to add 9 on both sides at the same time. On the left side we end up with 15. On the right side you end up with 2.5x. Now I'm going to write it like that for a minute, but that's kind of a no-no in mathematics. We don't write mixed numbers and variables next to each other, so we need to put this back into an improper fraction form. So 2.5 we would put back into an improper fraction form, so that's actually going to be 5/2 x. And then to get rid of the 5/2, we're going to go ahead and multiply both sides by 2/5. And we should be done at that point. Put the 15 over 1, do a little cross canceling. I can cross cancel the 15 and the 5 right here, and I get 2 times 3 and x equals 6, and that problem's done. Okay? So, a couple more. I'm going to try one, and then you guys are going to try one. All right? Number 5 gets us into the fractions. So you'll notice the left side, again, I can't break down a base of 6 at all. So there's nothing that's going to happen on the left side that's going to help me out. So I'm going to go ahead and leave the left side as 6 to the power of 5x plus 7. On the right side, I can actually make the right side a base of 6. So again, what I want you to do is I want you to ignore that exponent of x plus 10. I want you to think about the 1/36. 1/36 is equivalent to 36 to the negative first power if we flip it over and change the exponent. Or you could also say that 36 to the first power is equal to 6 to the negative second power. Okay, now whichever way works for you, if you think about 36, 36 is 6 times 6. Okay, so 36 is really 6 squared. How do I flip that over and get it into the numerator? I write it as 6 to the negative 2. So the 1/36 that was on the right side here, this is going to become 6 to the power of negative 2. But now I have to go back and reattach that exponent of x plus 10. And I'm right back to where we were originally. Okay? We're going to multiply the exponents on the right side, so we're going to have 6 to the power of, this time we're distributing a negative 2, so it's negative 2x minus 20. On the left side, we still have 6 to the 5x plus 7. And now we just set the exponents equal to each other like we did before. 5x plus 7 equals negative 2x minus 20. Add your 2x to both sides. At the same time, subtract your 7 from both sides. We end up with 7x equals negative 27. And divide out the 7. And x equals negative 27/7. That one would be a little harder to check, no question about it. All right? So right now on the right-hand side, on number 6, I want you to see if you can change both of the fractions, okay? Because 4 does not go into 32 as a multiple. In other words, 4 to the first power is 4, 4 to the second power is 16, but 4 to the third power is not 32. 4 to the third power is 64. So in the case of number 6, you're going to need to change both of these bases to a base 2. So both sides need to be changed to a base 2. Take a couple of minutes, have the sub turn off the video, and try solving that problem on your own. All right, so we're back. Hopefully you've got the problem done. First thing I'm going to do is I'm going to ignore the x plus 6 in the exponent up here. I'm going to take the 1/4 and I'm going to rewrite this as 2 to the negative 2. Because that's what 1/4 is. It's 2 to the negative second power. And 1/32 is 2 to the negative fifth power. So that's where I want to start. I want to start by converting the bases so that they are equal to each other. And then I can reattach the original exponents, x plus 6 and x minus 5. set those guys equal to each other, and rewrite with a single exponent on each side. So on the left side we have 2 to the negative 2x minus 12. On the right side we have 2 to the negative 5x plus 25. Once you've got the bases equal, set the exponents equal. Negative 2x minus 12 equals negative 5x plus 25. Let's go ahead and add 5x to both sides and add 12 to both sides. We're going to end up with 3x equal to 37. So x is equal to 37 thirds. Alright? So, homework is attached. You guys know where to find it in your notebooks. Be nice to the sub, and I will see you tomorrow.